For simplifying radicals, I want to start with example 1 down here, so that we can work through these steps given a problem. So the first thing is you got to know your perfect squares. Perfect squares are 1 times 1, or 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Make sure you're jotting all of this down on a piece of paper. 49, 60, 4, 80, 1, 100. And these really have to be known. Or you really just have to have a calculator handy to be able to do it. So these are our perfect squares. Okay, don't worry about 1, 2, 3, 4, 5. It's perfect squares are 1, 4, 9, 16, 25, 36, 49. These are perfect squares. And we honestly don't even use 1 because we're going to be basically like taking a part out of a number, and taking or dividing out a 1 leaves you with the number. So nothing really changes with the 1. When I first start, I always look at the number 84, and I always look for halfway. So half of 84 is 42. So I kind of think of that right here is where 42 would land. So the goal for the first step is to find half of the number. Because what we're going to be doing is we're going to be testing the perfect squares up to 36. A lot of people will just test them all, but honestly, it's got to be numbers that go into 84 or divide evenly into 84. And the smallest number that can divide into 84, that actually it makes something besides 84, would be 2. And 2 times 84 is 42. So that's where that cutoff is. So the second step, step 2, is you want to find the biggest perfect square that divides evenly. So this is where we need to have that calculator present to be able to do, basically we're trying to test 84 divided by 4 and see if it works out to an even number, which I think it does, 21. 84 divided by 9. And I don't think that works out to an even number, like it doesn't work out evenly, it has a decimal. 84 divided by 16. I don't think that works either. 84 divided by 25. And that doesn't work. 84 divided by 36. That doesn't work. So we need the numbers that worked. The largest perfect square that divides evenly into 84. So we can see that 4 is the largest perfect square that divides evenly into 84. So that's why I give people a cutoff, because otherwise then they're starting to test 49 and 64 and 81. There's no point in that, because they're not going to be divisible by it. Step 3 is to rewrite the problem with the perfect square and a number under their own radical. So we're not really changing anything here. We're going to put the perfect square first, 4, and the 21 second. We still have 84 under a radical. We've just split 84 up to 4 times 21, and we split those radicals up separately. Some people will want to write them under the same house at first. 4 times 21 is the same thing as 84, and then you can split them evenly as well. I always put my perfect square first because our last step is to simplify the perfect square. So radical 4, or the square root of 4, is 2. Radical 21 is this big, long, irrational number. Test it out and see. The idea is that we would just carry that irrational part down. We shouldn't have decimals or anything like that. So if you did radical 21 in a calculator, you'd see you get all these decimals. Well, that's not really what we're after. We're after having it, the rational part is here and the irrational part is over here. Let's try this. Let's try this with another one, like 108. I'm going to erase all this work over here. I'm even going to erase the halfway point over here, because half of 108 is like 54. So we're right about there. That's where we want to stop. What I've had some students say before is that they actually work backwards because you're trying to find the biggest perfect square. So I think 4 might divide evenly into 108, but so do other numbers along this list. So a lot of people will accidentally stop at 4 but not realize there's more to come. So one student once said, well, why don't we start with 49 and see if 49 works, which it doesn't. And then get to 36. And lo and behold, it does work. So then they didn't have to figure out that, well, 4 works, 9 works, and 36 works for 108. And the goal is to find the biggest perfect square that divides evenly in. So 36 is the number we want to focus on. So down the rules that we had done before, rewrite with the perfect square. So you might want to rewrite it where it's 36 and 3. I always put the perfect square first because that's the way we want to have it outlined in the end answer anyways. You might want to think of it as giving each one their own house. 36 gets its own radical, 3 gets its own radical. We still haven't changed the problem. But we can simplify radical 36 to plain old 6. And this is this irrational part. If we type in a calculator, works out to some crazy decimal. So we carry it down because our goal is to not have decimals for this. I always have my perfect squares listed to help me out. I want to try a couple more, like bigger numbers like 150. So I want you to think about, okay, 75. So our cutoff would be maybe around here, and try to work backwards and try to figure out which number divides evenly into 150. Take a minute and pause this video and restart when you have the number that divides evenly into 150, the largest perfect square that divides evenly into 150. So hopefully when you did your testing, you got 150 and you tried 64, 49, 36, but I do believe 25 works because it goes in evenly 6 times. So same thing what we were doing before, rewrite it so that it's still 150. I put my perfect square first, my other number after it, still is equaling 150. Give each one their own house. And then I can square root 25. And the square root of 6 is this funky answer. So I write down 5 radical 6. For number 4, 3 times radical 60, I want you just to ignore the 3 for a second and work on radical 60. So radical 60, perfect square, half is 30, so that leaves 25, which doesn't go in 25. Then comes 16 if we're working backwards. No, 9, no. I think 4 goes evenly into it. 15 times. So if I'm just worrying about radical 60, you can skip some steps too and skip right to the 4 times 15 to radical 5, or radical 15, sorry. But we've got this pesky 3 that I kept telling you to hold on to out front. That means multiply. It means the same thing as if you have 3 2 radical 15s. Total, if I had radical 15, radical 15, radical 15, radical 15, radical 15, radical 15. 1, 2, 2 radical 15s, another 2, another 2. There's 3 sets. There's 6 radical 15s total. Now, I don't want you to have to write all this out. I want you to realize that 3 times 2 could give you that 6. So the numbers outside of the radical can multiply. Numbers under the radical can multiply. Let's try another example. So I picked other ones because these are the ones you might see in our course. But like radical 23 squared, I know a lot of people are typing this in a calculator. It might not give them the right answer. So be aware that radical 23 times radical 23 means what? Right? So it means there's a couple ways to think about it. Some people might say, okay, well, I'm going to start doing my math. Okay, so radical 23 is 529. Okay? If you square root 529 in your calculator, it spits out 23. Because when you square something and when you square root something, you're basically doing opposite operations. So when you square 23 and then square root it, your answer will be 23. If you think about the Pythagorean theorem, at the end of the Pythagorean theorem, sometimes you get a problem like this. C squared equals 100. And most people square root both sides and get 10. Well, you're squaring and square rooting C, which is leaving you with C. Another problem is these, anytime we've got radicals like this, it's chaos. Okay, so you could try typing that in a calculator. You can try figuring it out. Just keep in mind that sometimes showing a little work is not such a bad idea. Like 2 radical 5 times another 2 radical 5. The numbers in front can multiply. The numbers underneath can multiply. And I think I even know radical 25 is 5. And our answer should be 20. So you can do the math in a calculator. Make sure it's spitting out 20. Okay, for this, you can square each one. 4 is 2 squared, and 5 is radical 5 squared. And it gives you 20. A lot of different ways to get there. So hopefully you're getting a better understanding as to how you may have simplified perfect squares in the past. And now it's time to practice simplifying perfect squares on your own.